All right, everybody, we're going to check out applications of quadratic equations. So here we have number 7, find two real numbers that have a sum of 6 and a product of 8, right? So a lot of times when we hear applications, we're dealing with word problems. And I know sometimes those can be intimidating, but we'll just keep an open mind and we'll press through it, right? And with word problems, the more familiar you are and the more experience you have, the easier they are, so hopefully they're not going to be a big deal for you when it's all said and done. So and maybe even right now you're thinking that this is pretty straightforward. So all right, so find two real numbers that have a sum of 6 and a product of 8. So whenever we're doing word problems or applications, we want to go from words or a situation to math. A lot of times we need to define our variable, right? If we're going to solve this algebraically, we want to define our variable. So in this case, we're looking for two real numbers. So we'll let x be one real number. All right. And then, so the other number, we could call it y, right? But remember that our quadratic formula and, our factored method and all those, we're using one variable, right? We're solving for one variable, not two. We don't have a system of quadratics. So we want to try to keep it in terms of the same variable. So instead of using y, we want to use something with x in it. So let's use the context here. So we have a sum of 6, right? So that means the two numbers add up to 6. So if one of those numbers is x, then what would the other number be in terms of x? That's right, yeah. If one was 2, the other would be 4. If one was 3, the other would be 3. If one was 1, the other would be 5. So in other words, we're just subtracting 6 minus x to get the other number, right? Okay. All right. And so we have our two numbers defined in terms of x. Now we want to set up our equation. So let's look at the second part of the sentence. They have a product of 8. So that means if we multiply them together, we get 8. So that's pretty straightforward, right? If we multiply the first number, x, by the second number, 6 minus x, then our result is 8. All right, so here we go. So now we don't need the words anymore. We have our equation. It's a quadratic equation. So now we can solve for x. So it might not be as obvious that it's a quadratic equation, but as soon as we distribute here, now we can see that it's a quadratic equation, more obviously. All right, so now we have some options, right? We've gone through really 4 different ways to solve quadratics, right? We can use the factor method. Okay. All right, we have the even root property method, right, where we isolate the squared variable. And then we have the quadratic formula. And then we have completing the square. And completing the square we talked about just briefly in order to derive the quadratic formula, right? So we haven't had as much experience with that, and the whole reason we talked about that was so that we could generate the quadratic formula, right? And so anyway, so the good thing about both of these is they both always work. The quadratic formula and completing the square work for any scenario, whether you have a rational, irrational, or an imaginary or complex roots or no solution. Whereas factoring and even roots kind of have to be set up nicely, right? Even roots, you have to have a situation where you have a squared variable or even powered variable and no other variable, right? So the fact that we have a 6x here with the x squared means we can't do the even root, because I can't isolate x squared with, equal to just a plain number. I would have a 6x on the other side, and so I won't be able to just take the square root of both sides, or and so we know that this one doesn't work, okay, in this situation. So that leaves us with factoring the quadratic formula, completing the square. So out of these two, quadratic formula and completing the square, quadratic formula is probably the most straightforward way to go. And then factoring is also a possibility. So if I want to decide between those two, remember, for each of these, you have to set them equal to 0, right? Not for the even root, but for the ones that were, for all the other three, you have to set them equal to 0. So let me do that first. So I'm going to add x squared to both sides and subtract 6x. And the reason I'm doing this The reason I'm moving everything to the right is to get this to be positive, right? Because in order to factor, or at least to use kind of the rules that we use, the factoring rules, it's a little easier to get your squared term to be positive, okay? With a quadratic formula, it doesn't matter. So if you want to use a quadratic formula, you can go ahead and just subtract 8 from both sides, and it doesn't matter if this is negative. But since we're kind of on the fence, we'll do it this way. Okay, so now that I'm here, to check to see if I can factor, I can either just do a quick, run through. Do I have two numbers I can multiply to get 8 that I can add to get -6, or to get 6 in general? And the answer is yeah, 4 and 2, right? So if it's that easy, you might want to factor, right? If you can't figure out whether or not you can factor, one thing you can do is use the discriminant. Because remember, if the discriminant, which is b squared minus 4ac, if that comes out to be a perfect square, that means it's factorable, right? If it comes out not to be a perfect square, that means you're going to have an irrational situation and it's not factorable, okay? So that's one way to check. Another way to check, if you're not sure if the numbers didn't pop out as easily as just 4 and 2 that we just had, then you can make a list of, oh yeah, what are the factor pairs that I can use to get whatever this number is, or a times c if it's a complex quadratic. Okay, and if you exhaust your list here and you don't find numbers you can add or subtract to get that middle number, then you won't be able to factor. Okay, all right. So on this one, it could go either way. I'm going to show you both solutions, but I'm going to factor first. That, to me, that's the easier way to go if it's a simple quadratic and it comes out easy, 4 and 2. I think that's the fastest way to go. So let's see. So I know it's 4 and 2. The sign of the bigger number is going to be negative because the 6 is negative there, the b. Okay, and then this sign tells you whether the signs are the same or different, right? So since that's a positive, that means the signs are the same. So that means this has to be negative, right? Because a negative times a negative equals a positive. All right, so then our two answers are 4 and 2. And this time it actually gave us both solutions, right? We could solve for the other, like if one number is 4, 6 minus 4 would be the other one, that's 2, but we already have 2. Same thing, we can do 6 minus 2, and that gives us 4. So our two numbers are 4 and 2, in whatever order you want to put them, okay? So I'm going to freeze the video, and then I'm going to show you the solution. I'm not going to work it out, but I'm just going to show you what it looks like if we did the quadratic formula, and you can decide which one you like better. All right, so here, side by side, you can see right here is what it looks like if we use the quadratic formula. All right, and then here's what it looks like if we factor, right? Now notice, you might be wondering, well, what about all the stuff above? Well, this stuff above that we had to do no matter which method we choose between factoring or the quadratic formula, right? All right, so you can use either method, whatever you think is easier. To me, this is quicker if we have the option, and especially if the numbers come to us quickly. But this one always works, right? No matter what. So if you just want to say, hey, I want to do the same thing every time, the quadratic formula might be your best bet. But it's nice to be kind of versatile and be able to work in different situations and be, as efficient as possible.